Hello guys, we're again together after a long time. This is the third experiment and this will be the last experiment on this turn. So let's get started. Let me introduce you this setup. Uh, it is called ball and beam experiment. It is mainly composed of a beam and you can arrange the angle of this beam and also you can arrange the position of the ball, as you can see. This beam is connected to a DC motor and you can control this angle by computer. Okay. Also the setup measures the ball's position by these metallic wires on the beam. So there are two arguments, as I said, the angle of the beam and the position of the ball. So in this experiment we're going to control these two arguments. Please open the lab manuals that I sent you and open 6.3 experiment 2, proportional control of beam angle and manual control of ball position. Before starting, let me introduce you the software. We can set a circuit here, and we can assign input value as if we want. We can arrange some frequency values, even the type of the function. Also, we can set some controller gains, and we can here is the experimental setup, and we can see the results here. Also this screen shows the error value. Now we open 6.3 experiment 2, proportional control of beam angle and manual control of ball position. Now we start with first part, to control the angle of beam. Now let's run the experiment and see what happens. Now there is no actually feedback, so it's an open circuit, actually open loop control. Let's see what happens. You see the angle is rise and decreased. Okay, now let's connect the angle. Now we fed back the angle. Also, to read the graph. Okay. The KP is set to 1. The frequency is 0.1 Hertz. Also, the level is 2 volts. Okay. Now let's run the experiment. You see, here is the just proportional control, and also there is steady state error. Okay, now we can skip to part C, and we're going to repeat this procedure for okay. You see here the results. We can try this same procedure for some other values of KP. Now let's arrange it to 2. there are some overshoots, and I think the steady state error is decreased. Now let's make it 3. You see, more overshoots, less steady state errors. You see. Now let's increase to 4. Which is, critical value. So it's keeping the oscillating. So what if we make it 8? You see? Okay, we can start. Let's put the results here. Y-axis. Let's arrange it to 8. Now we skip the part 2 and we directly go to the third part, manual ball position control. So we're going to see how hard is to control the position of the ball. Now in part 3 it says turn on the potentiometer. First let's make 0 this function generator, so it's not functioning now, so we're going to put a potentiometer here. And connect it to input here. Also we can connect the set value here. Okay, now we're going to set the position of the ball manually by arranging the angle. So in part A it says place the ball on the center. Let's bring it to the center, and we are going to try to keep it between plus and minus 40. Okay, let's run the experiment. Okay, I just arrange some voltage values. Let's come to it is very hard to control it manually. See? Here are the results. Okay, the part B is also same, so we try to keep the ball between minus and plus 40 centimeters. Okay, we saw it is very hard to keep the ball in a position. Now we skip to the main part. Now we are in part 6.4 experiment 3, phase advanced control of ball position. In this experiment we're going to control the position of the ball by a phase advance block. So first we arrange the KP value to 8 here, and the gain value of the phase advance block to 0.1. Okay. Also we read from the graph the position of the ball. Okay. Now everything is all right. So let's bring the ball to center. Okay. Now we can run the experiment. I think there is some problem with the gain value of the KP. Let's try it 3. Okay. Remember the 3 value was, or 4 was the critical value when we brought the KP to 4, so it started just fully oscillating. So 3 is a good value. Okay. Now the experiment is still running, and let's check it whether it is controlling or not. You see, it's changing the angle. But there are some errors values. You see? Okay, we can in part B we can change the reference position. We can increase it, for example, here. Okay, let's bring it here, just in this circle. Okay, let's again give some interference. It's again coming its original position. Okay, we can also try the other side. For example, minus 4 volts. If we give, it just stays there. Okay, very nice. So varying the phase advance gain KP2. Now we are required to turn the potentiometer to move the ball to various positions on the beam, and notice that the error in beam position can be quite large. Yes, let's again come to 0. You see there are some errors. It is not perfectly in 0 position. The center is here, but the ball is not at the center perfectly. Now we are going to in part B we are going to increase the phase advance gain here. Let's make it 0.3 and see what happens. You see the response is much faster, but response is faster. But there are some problems with the position of the ball. Now we are required to set the this game value to 0.5 in part C. It is much faster again. I'm sorry. Okay. But the error value is very much again. Okay, so how can we decrease the error value? For example, if we set to again, for example, 4, what happens? You see the oscillations. Maybe 3.5 is all, maybe better. Yes. Okay. Better. Okay, much better. Now we have fast response and better steady state performance. What's your problem? Come here. Okay. Now we are in another part, varying the phase advance T and alpha parameters. Now we are required to move the ball from 0 position to 20 centimeters. We're going to arrange the potentiometer. To 20 centimeters. Okay, now we are on 20 centimeters. Switch the phase advance controller alpha to 0.05 and T to 6. Okay, so let's interfere it. You see the beam has a faster response. Compared to the previous values. Now let's switch alpha to, okay, let's keep it same, and T to 1. What happens? Okay, it was here and interfered. Now the response is slower and it is less stable. Also, oscillations are increased, you see, compared to the previous case. Okay. Okay, let's stop it. that was all for this experiment. Thanks for watching. I will post homework for this experiment. Also, you're going to prepare a short report. That's all. So good luck and see you again.